Hi, I'm Rebecca Ringette here from the Community Coordinated Modeling Center to talk to you about one of our tools called Kamodo. Kamodo is an official NASA open source project based upon the idea of functionalizing a given data set. All of the notebooks that I'm about to show you in this short demonstration are located on our public code repository on GitHub. So we're applying the capabilities of Kamodo to heliophysics model outputs so that our users have a model-agnostic interface to the model data that we host at the CCMC. We handle all of the custom coordinate systems behind the scenes. We handle the various file formats and the various coordinate grids, whether irregular or not, or even nested coordinate grids, all of it behind the scenes with interpolation placed on top of that. By doing so, we are able to offer our users the various capabilities of Kamodo for heliophysics model outputs, such as unit conversions, function composition, and very nice looking plots that are interactive. We have a growing number of model outputs supported by CCMC's Kamodo. And once the user decides what model they want to functionalize, what data set and what variable, the syntax is the same regardless of the model. I'm showing here a few blocks of code, and the 2 lines on each block are the syntax to functionalize a given variable in a given model output. Notice the syntax is identical regardless of whether this is the CTP model, the GETA model, the Wacom X model, or any other model output that we have worked on. Once that is done, the user can easily create sliced plots in 2 dimensions. You can compare side by side what the one model predicts compared to the other, say for CTP and GETA. And you can even compare the predictions on the same plot for as many models as you want functionalized. Here, I'm showing 3 of them. We have extended this idea to a fly-through functionality. There are several flavors of this fly-through functionality. I'm only sharing one of them. But notice that the command for the fly-through function chosen is going to be the same regardless of what model or what the model output is asked to be functionalized. So the various fly-through commands fly a given trajectory through the model data and returns a dictionary. That can be easily functionalized using this command, this highlighted command, repeatedly. And once that data is functionalized, you can use the capabilities of Kamodo. In this case, I'm showing several function composition commands, which are used to perform some simple ensemble analysis. The user can then easily plot all of these derived and interpolated variables onto one plot. And all of these plots have the same Plotly basic features. You can zoom, you can turn variables on, you can turn variables off, you can save the interactive functionality for later use, so on and so forth. You can also do this for observational data due to our interface to the HAPI server, to various HAPI servers. In this case, we're pulling observational data from the Cindy instrument, so that we can compare the temperature data from Cindy to our model average predicted temperature calculated earlier. We can take this process one step further and use the fly-through in something called a reconstruction tool. This is a satellite constellation mission planning tool that can be used for mission developers to figure out what constellation arrangement and number for their constellation is the best fit for their science goals. There are a lot of different options here, so I'm not going to go through that here. Feel free to come check out the poster. But the point here is that the syntax is identical regardless of the model, what variable you want, and where that data is located. All you would have to do to run this command for a different data set is to change these 3 variables. The rest can be the same, and it runs identically. Some models take longer than others, but there you go. But you can use this to figure out what your satellite constellation would see versus what the model predicts, and then use the various features of Kamodo to compare those. In this case, a % difference comparison. On the commercial side of things, Ensemble Government Service Services has built a code-free interface on top of Kamodo. In this case, this particular one is that I'm showing here is studying the effect of drag on satellites, which is a hot topic lately. In this case, it's showing the GitHub model data. You can investigate it using various features of the code-free interface, as I'm showing here. And it updates, no code required. And there's some additional features here to investigate drag. If you want more information, please feel free to visit the CCMC website and our GitHub. And also you can go to the AGU full schedule and search for Kamodo and come visit one of our posters and talk to us. Thank you.